Hello, everybody. This is Psych 3280, Neural-Based Consciousness, week 10. And this week, I'm going to talk about the consciousness and the integration. So to recap week 10, I introduced the theory of consciousness called the IIT, Integrated Information Theory. And the key part of the theory is that it starts from the phenomenology to the mechanism. And in terms of the phenomenology, IIT suggested 5 critical properties that are true for any kind of experience. It's intrinsic existence, composition, information, integration, and exclusion. And this week, I'm going to talk about more of the information, integration, and the exclusion. And based on the phenomenological actions, IIT proposes the 3 steps. One is the first to identify the system level integrated information, and then to identify the level of consciousness for a system, and then to find the subset of the mechanisms that maximizes system level integrated information, and that defines the boundary of consciousness. And this is a part that I'm going to talk more on this in this week. And then the next week, I'm going to talk about the pattern of integrated information among all subsets of mechanism within the boundary. And that specifies the contents of consciousness or qualia, how we experience the world at each moment. And then in addition to these phenomenological actions and also procedures of IIT as a whole, I also introduced the IIT-inspired measure of consciousness, and that is a perturbational complexity index, or PCI. And based on the idea of the integration and the information, we consider the 8 neuron systems and discuss about sort of possible simulated kind of response or expected response when you directly stimulate the brain using TMS, transcranial magnetic stimulation, and then to look at the evoked response using EEG, electroencephalogram. And what I said was that in the case of when consciousness is expected to happen, such as wakefulness or REM sleep or locked-in syndrome or minimally conscious states, then the evoked response when you stimulate one particular electrode in this red, then that propagates not only from around the neighborhood, but also goes to other areas of the brain, in the opposite area or back and front and so on, and here as well, to generate sort of a complex evoked response, and that results in high index PCI index. And on the other hand, the cases where we expect the less conscious experience, such as non-REM sleep or anesthesia, non-REM sleep or anesthesia or vegetative state or unconscious wakeful syndrome, then the evoked response is either confined locally or evokes really huge response, but across all the areas uniformly. It's like too much integration. And in the end, the resulting pattern looks kind of simple. And that is also captured by this lower index of the perturbational complex index using the ZIP algorithm, basically Lempel-Zip complexity. Okay. So the learning objectives for week 11 is that the following. One is that unlike this approximate approach of integrated information, we want to know how exactly can we compute the integrated information, and then why it's difficult to compute it for the entire brain. We need to understand why this is, and then what's a challenge and what can be solved and so on. And then based on this understanding, I'll talk about what is the boundary of consciousness proposed or predicted from the integrated information theory. And then using these concepts, I'll talk about whether we can explain the properties of consciousness using these type of, according to IIT. So in terms of the reading material, I suggest chapter 17 in Quest for Consciousness that describes a split brain patient. And then also as an optional reading, I suggest my own paper written for the philosophy compass. That is explaining the IIT without mathematics. Okay.